It's Sunday, June 15th. The weather has changed, so let's just go straight into it. Today, there is enhanced risk for severe weather, mostly driven by a damaging wind threat and a damaging hail threat. The hail being 2 to 3 inches in diameter. Some damaging wind gusts could be up to 75 to 80 miles per hour, are likely across parts of, I'll say, central eastern Montana into northeast Wyoming and the western Dakotas. I think additional strong storms would probably occur throughout the central southern plains over parts of Virginia and North Carolina. Now that's for the day 1 outlook. Let's go over here to the day 3 outlook. Now, we don't know a lot about the day 3 outlook, only that it's at a 30% hatched risk, with the regular 15% being right there, and with a new marginal risk centered over there. Now, let's see what's going to cause this. Day 3 outlook, people have to really keep an eye. The synopsis is a shortwave trough would move east across the upper Great Lakes with a cold front from parts of the lower Mississippi extending southeastward into Kansas. Meanwhile, a larger low amplitude trough will continue moving across the Rockies to the high plains by 0Z. Low pressure forecasted to develop over the Texas and Oklahoma panhandle, with a dry line extending southward into northwest Texas. Now, let me explain to you what a dry line is. A dry line is basically a pocket of warm air that's like no moisture. And that's why they have this as a enhanced risk, because there's going to be a lot of dew points being drawn up from the Gulf, 70 to 80s. And then you're going to have a whole bunch of cold air. No, not a whole bunch of cold air, my bad. A whole bunch of dry air in Colorado. Their dew point is going to be like 20 to 15, so that's very dry. And right there in the middle is where the severe weather is going to happen. Now, what's also going to be very good for these storms is that a large area of strong instability will exist over much of Kansas, Missouri, Oklahoma, and Arkansas, with MU Cape around 4,000 to 5,000 joules per kilogram, possibly supporting significant damage wind, locally significant hail, and a couple of tornadoes. Now, think of that as like thunderstorm fuel or food for these storms. This is basically, whenever we see stuff like this, that's what you guys see when it's like strong instability or like strong buoyancy. That, with the cape and stuff, that is just basically thunderstorm fuel, and any storms that you see popping up in that area will be significant, with a couple of tornadoes and significant hail. Now, this isn't really good. I mean, we knew this was going to happen, but we didn't think it would be this far out that we could predict that the Cape would be this high up. That's pretty bad, because with this, we've seen it before, and it's not really good. But let's continue to read on. Later in the day, the air mesh south and west of such convection system or residential outflow would become very unstable, while capping will limit southward development over Oklahoma, and the panhandle's hot temperatures and southwest flow across the region will combine with the 70 dew points over Kansas, yielding late afternoon and evening storms. Slow moving supercells will be possible initially, especially near any cold old outflows where SRH will be maximized. Both tornadoes and large hail will be possible. Otherwise, an increasing southwest low-level jet to 50 knots will be supporting a severe mesoscale system across Kansas and perhaps into western Missouri. Late damaging, potentially destructive wind gusts may occur. And what they mean by a low-level 50 knots, all right? That is just showing us how fast the jet stream is moving, how fast the winds are, like 500 millibars up in the air. That is basically what that is. Now, let's go over and look at the day 2 outlook. Now, for the day 2 outlook, there is a 5% chance for tornadoes, so that's not really good. We have a 30% chance for damaging wind, not a hatched risk. So, let me explain to you what a hatched risk is real fast. So, a hatched risk is basically, let's say this is hatched, all right? It's going to have a bunch of lines. And anywhere within those lines is so let's say the wind gust was 75. Well, in a hatched area, it's like 80 to 85. So, anywhere within there, or any Any 25 miles within a given point, you'll see a heavy wind gust. And then for the hail, it's hatched. So, possibility of 1 inch in diameter hail or greater within 25 miles of a point. Hatched area, 10% or greater probability of 2-inch diameter hail or larger within 25 miles of a point. And right there. Now, let's see what is driving this system. Causing this is a early shortwave trough associated with a mesoscale convection system. We move east out of North Dakota across northern Minnesota during the day with modest westerly aloft behind it over the Central Plains and Northern Rockies. Height falls will occur behind the northern wave as it breaks down the ascent ridge. Mid-level temperature will gradually be cool with around negative 10 degrees Celsius at 500 millibars. At the surface, a trough will exist from northern Minnesota near the convection system, southwards across. Mean for storms will, with a nocturnal low-level jet aiding overnight, develop further across much of the area. Now, a mesoscale convection system is likely going to be ongoing Monday from North Dakota into Minnesota, with associated mid-level wave. As this feature continues east during the day, a conditional threat of supercells will develop along the southern Hypersea, even if only mesoscale convection systems. By afternoon, here a low-level lapse rate plumb will be out of southwest. A couple tornadoes may occur along with large hail. Additional isolated cells will be possible, trailing southwestward across southern Minnesota into northern Iowa, and perhaps southeast South Dakota, and northeast in favor of large hail. Potential will be strong instability with 3,000 joules per kilogram MU Cape. However, deep layer shear appears less than optimal, suggesting more of a localized significant hail threat. Otherwise, enhanced low-level shear near along the southern hypersea of the mesoscale convection system and the mesoscale vortices. Influence may yield tornado potential. Now, what those are, so think about really severe storms, but after you see all those clusters of storms on radar, that is what these form into after those go away. So after those storms die out, that's what those goes into. Now, let's look at today. Let's go back to the 4 to 8 day convection outlook. Now, I was a little bit right. They did extend this. I'm thinking I could be wrong. They might extend this further to where it reaches into Kentucky a little. I'm saying like they could extend it from right here to right here, or they could just extend that whole entire thing. I don't think that's going to be possible. I think they're extending that because look, if we go over to the day 5, if we see on the day 5 outlook, they have the 15% over here. And what I'm thinking is going to be moved over here because it stays at day 5. Is that if they do update it, it'll make more sense because these storms, if you see how they're niggly, if it's tilted like this, it normally kind of straightens out as it goes through, but then goes back into a niggly tilted area. So it kind of forms into a squall line, or more or less a cluster. Now, let's see what is driving this 2-day severe weather outbreak. This trough that's going to be associated with this, a mid-level trough is forecast to move into the lower Great Lakes and upper Ohio Valley on Thursday as a cold front advances into the central Appalachians. As the air mass ahead of the front destabilizes, scattered thunderstorms are expected. Now, let's talk about the destabilization. What it means is that think about the air being so perfect, all right? Like, it's not too hot, it's not too cold. But storms, they can't live in that. So what destabilization means is that basically, if the sun comes out, it's going to destabilize the atmosphere, heat it up so these storms can just break through the atmosphere and be like, they just rise. These types of storms, I could be wrong, but supercells could rise up to 30,000 feet. And those are the type of supercells that produce those long track tornadoes. Now let's go into Friday. Now, a shortwave mid-level ridge is forecasted to move into the upper Mississippi Valley on Friday. The ridge is forecast to remain over the region on Saturday. As a mid-level height rises beneath the ridge, a moist and unstable air mass will likely be in place from the lower to mid-Missouri Valley, northeastward into the western Great Lakes. Within this air mass, isolated thunderstorm development should take place both Friday and Saturday afternoon. Instability and deep layer shear appear sufficient for localized severe threat. However, the precise of the ridge introduces uncertainty as to where the greatest potential for convection will be. For this reason, predictability is low. Now, let's talk about the instability and the shear and deep layer shear. So deep layer shear is up there in the clouds. Now, that is what has the storms have spin. That's what gives them rotation. That's what deep layer shear is. Deep layer shear, whenever we get our damaging wind gusts, that is a result of the deep layer shear in the clouds breaking down. Or a microburst. A microburst is a really fast downdraft that's 1 mile long and 2 miles in diameter, and releases like penny-sized hail and some gusty ones for about a minute or two. But yeah, that's what's going to be causing that. On Sunday, mid-level trough is forecast to develop over the Rockies as the ridge moves into the Great Lakes region, although a moist and unstable air mass should be located over parts of the northern and eastern U.S. Large-scale ascent for mid-level flow is forecast to be relatively weak in most areas. For this reason, any severe potential is likely to remain isolated. Now, I want to do a little bit of some debriefing on this. Now, normally, if it's 6 to 8 days out, it's so far out that the models, they're just making a prediction. Like, they're just throwing stuff out there. I think the aloft and mid-level flow, it will increase, and the ascent will. Now, let's talk about the large-scale ascent. So storms, they need these things called a updraft. An updraft is what keeps storms rising and keeps them in place. Now, if you get the mid-level flow, that is they get that large-scale ascent and mid-level flow, that relatively makes tornadoes. Not necessarily, but that is rotation and updrafts. Updrafts, alright. Here's another thing with the updrafts. Updraft keeps raindrops in the air, right? That's why with some tornadoes, you don't see it all the time, because the updraft isn't so strong that it is strong enough for it to support the tornado, but not strong enough for it to support the raindrops. So that's why in some tornadoes, there is hail. Now, with some of these tornadoes, with the hail and stuff, they will be in the air for so long to where it gets so heavy. Yeah, hail, it gets so heavy to where the point, the updraft is still strong, but the hail is so heavy to where the point, the updraft can't hold it, and that is what releases hail. Now, if you're ever out and about and you see my Weather Channel thing, that is a meteobolimbus cloud. That is like a backside of a supercell, and it's intensifying. But that is all the weather talk for today on Sunday, June 15th. Wish y'all the best of luck, and yeah, Weatherman William out.